Section 11.2 is an introduction to matrices. A matrix is a rectangular array of numbers that we denote with the brackets. We talk about the rows, which go left to right, and the columns, which go up to down of a matrix. So, for example, this matrix has 4 rows and 5 columns. We'll talk more next section about how we label them, but we always label them rows by columns. So we would call this a 4 by 5 matrix. Each number in the matrix is called an entry, and we label the entry by their row then column. So for instance, if we want to talk about this number 26, we would call that entry number 2, 3, because it's in the second row and the third column. And we use matrices to represent systems of equations, especially one type of matrix called an augmented matrix. As we move up in linear algebra, computer science, we'll be talking about systems that have 5, 10, 15, 100 variables. So instead of writing out all of those equations, we use matrices as a way to organize those systems. So if we have this system here, then we can create an augmented matrix. The difference between an augmented matrix and a regular matrix is basically this bar that represents the equal sign. So we have a column that lists all the x coefficients. We have a column that represents all the y coefficients. This bar represents the equal sign, and then we have the constants on the right side. So this is how we create an augmented matrix, and we can create it for any size system. So if you had a z variable, you'd have a third column before your bar. If you had 10 variables, then you'd have 10 columns before your bar. If you had 10 equations, then you'd have 10 rows. Each row represents a different equation. So here we have a system of 3 variables with 3 equations. Go ahead and pause the video and write the augmented matrix that represents this system. Take note that this first equation doesn't have a z, but you still need to hold a place for it in your matrix. So you have a column for each variable coefficient and the answers, and you have a row for each equation. So you end up with your augmented matrix to look like this. Make sure you have this 0. There's 0 z's in the first equation, so you still hold a spot for it. One method we have for solving systems using matrices is what's called row echelon form. So row echelon form says that every entry ii, so basically the entries with the same row, same column number, are equal to 1, and that anything below that are equal to 0. So what that means, if you start in the top left and create a diagonal down right, all of those are going to be 1s. Anything underneath a 1 is going to be a 0. Everything else can be anything. It could be a 0, it could be a 1, or it could be a 17. It doesn't matter. It can be anything else. So top left to bottom right are 1s. Anything below that is a 0. Anything else is anything. So we use this to help us solve systems of equations. The way that we get a matrix, an augmented matrix like this one, into row echelon form is using what's called row operations. There are 2 types of row operations you can do. One, you can multiply a row by a constant. So think of elimination, where you can multiply an equation by a number, and then you just distribute that to every coefficient in the equation. So you can do the same thing in matrix form. You can also add or subtract a multiple of a row to another row. Again, think of elimination when you multiply a row by something or an equation by something and then add it to another equation to simplify it. Basically what we're doing is elimination method. We're just doing it in matrix form instead of in equation form. So when I'm doing row operations, the first thing I always do is I always start with the upper left-hand corner and make that a 1. So if I want to make a 3 a 1, how would I make 3 a 1? So a lot of you might think, okay, I'm going to subtract 2, but that's not one of our options. We didn't multiply a row by a constant, and we didn't add or subtract a multiple of a row to another row. You can't just subtract a constant. Another way I can make 3 a 1 is by multiplying it by 1/3 or dividing it by 3. So what I'm going to do is I'm going to multiply my first row by 1/3 or divide it by 3. So basically I'm going to divide every coefficient by 3. The way I write that out is my new row 1 is going to be 1/3 of my previous row 1. So I multiplied everything by 1/3. So 3 times a third is 1. That gives me my 1 in this upper left-hand corner that I want. 4 times a third is 4/3, and 7 times a third is 7/3. I did not touch the second row, so I just left it. I just rewrote it exactly the same way. So now my top row is done. I have a 1 in the upper left-hand corner. Doesn't matter what the rest of them are, so that's done. So now I'm going to drop down, and I want to make this 4 what? Well, it's below a 1, so I want to make this a 0. So how am I going to make a 4 a 0? The only way to make a 4 a 0 is to subtract 4 from it. But the way that I'm going to subtract 4 is it has to be one of these. So I'm going to add or subtract a multiple of another row. So right above it, I have a 1. If I multiply this by a 4, I can subtract these and get 0. So think about elimination method. If this was my equation in elimination method, I would multiply this by 4 so that when I subtracted them, my x's would go away. That's exactly what I'm going to do. My new row 2 is going to be my old row 2 minus 4 times my row 1. So I didn't touch this first row, so I'm just going to leave it the same, 1, 4/3, and 7/3. Now for this first one, I'm going to have 4 minus 4 times the row 1, the entry right above it, so times 1. So 4 minus 4 times 1, that's just a 0. Now if I move 1 to the right, I'm going to have my row 2 entry, which is -2, minus 4 times the entry right above it, 4/3. So I'm going to have -2 minus 4 times 4/3, which ends up being -22/3. And then I'm going to do the exact same thing for this last entry. So go ahead and pause the video and find what this very last entry is going to be. So I'm going to have my row 2, 5, minus 4 times the entry right above it, which is 7/3. So 5 minus 28/3, which is -13/3. So now I have my 0 underneath my 1. So I'm done with this. Now the next step is making this next 1. So I want to make this -22/3 a 1. So think about what we did in this first step to make my 1 in this first spot. How are we going to make this -22/3 a 1? So go ahead and pause the video and try it. Make this -22/3 a 1. You're not going to touch the top row, so just rewrite that. And then figure out what your new row 2 is going to be. So in order to make this -22/3 a 1, I multiplied by the reciprocal, -3/22. So I do 0 times -3/22. Well, that's just 0. That's why we make this a 0 first. And then -22/3 times -3/22 would be 1. -13/3 times -3/22 would be 13/22. So now what you have to remember is this started out as your x column, your y column, and your constant column. So that stays the same. This is your x column, your y column, and your constant column. So now we have two equations. We have the equation x plus 4/3 y is equal to 7/3, and we have the equation y is equal to 13/22. So basically we've solved for y. Now you can plug that into the other equation and solve for x. So go ahead and pause the video and solve for x. So if you plug in 13/22 for y, you end up with x is equal to 17/11. So your solution is 17/11, 13/22. One thing I did forget to mention is there's one other thing you can do with row operations, and that's you can switch two rows. So for instance, I could have started out by switching row 1 with row 2. It doesn't matter which row you write them in. This is helpful if you have something that's easy to make a 1 or already a 1. Maybe if this was already a 1, I could have just switched these rows and it would have made a 1 in this upper left-hand corner. So there's actually 3 things you can do. You can multiply a row by a constant, which is what we did here. We could add a multiple of a row to another row, which is what we did here, or you can switch two rows. Just keep in mind when you are adding, it has to be a multiple of the other row, so just like elimination form.